All right, we are going to spend more time on day 2 of object-oriented programming, just digging further into the world of object-oriented programming. We're going to learn about what are called class attributes and class methods. And along the way, we'll do some review of what we learned yesterday with getters and setters and classes and instance attributes and instance methods. So we're going to talk about instance versus class attributes and instance versus class methods. And just maybe as a bit of a warm-up before we dive into this too much, let's create a student class. And I'd love to do a little group coding here and get a little guide from people. Let's just create a student class. Let's add 1 or 2 instance attributes and 1 or 2 instance methods. Can someone get me started and tell me what to type? We're going to be doing a lot with students this week. And we already did a lot with dogs yesterday. So I figured this is a good way to go. How do I make a class named student?
Can I guide you? Yeah.
Please.
So we just define the class name. What do you want to call the class? Student, colon. And then we will define the attributes for this class by self, open the parentheses.
Okay. What's the name of this method that we're going to create here?
You want to create method?
What's the name of, do you want me to make a method? And if so, what name should it have?
We start with making first the attribute for the students, right?
Correct.
So we define the attributes by using the, 2 underscore after define in it.
You got it.
Okay, and then, inside the 2 parentheses, the self.
Yep, and then you were saying in here we can define some attributes.
And define the attributes of the students, like the name, like the grade, like or the year, the which grade, which self.
Yeah, and I'll just do a number for 12.
Okay.
We're not awesome. Thank you, sir. Let's see, as we do this. So as I call on people, by the way, you can always phone a friend if you have a question. And Murad, would you like to pass the mic to anyone, or does anyone actually I'll just ask, does anyone want to go next? Tim, yes, sir.
You're muted, Tim. And while he's unmuting, hey, does the class have to be capitalized? I know that most classes are capitalized. Is that a true statement? I don't know if you said it yesterday.
Oh, great point. You mean capitalizing this first letter, the student class?
Exactly. Yeah.
Can I answer this question? Because
I appreciate it. I got it just in the interest of time. Normally I'd love folks participating, but this one's a quickie. It doesn't have to be, but by convention it should be. Class name should start with an uppercase letter. And in fact, like if this was multiple letters, it would be camel case, like student logbook or something like that.
Okay. Copy.
Yeah.
It's kind of like yesterday we said the pound sign is a method sometimes. The hashtag.
Oh, I see. So when I was saying that yesterday, what I was talking about, if we're writing, like this is a comment. If you see, like, say student, say hello, that's when you're writing comments and documentation, a way of indicating that we're talking about a method named say hello that belongs to this class. Does that answer your question then?
Yes.
Yeah.
Okay,
question.
So for the first defined function or whatever, you need to add name and grade to that. I don't know what else you wanted to add, but in terms of what
you would place. Start. Yep.
Okay.
And why do we need to add name and grade? What do you want me to do with them?
Since you added name and grade, you're trying to identify them inside of the self function or whatever you would want to define that as inside of that function, basically. Like I'm defining the name, blah, 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 and the grade, blah, 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 inside of this function.
Yeah, so we've got our init method, and as Morad was pointing out earlier, when we create instance attributes, we're probably going to create them here. Excuse me. I just had to grab a glass of a drink of water. We're probably going to define most of our instance methods here inside this dunder init method, because when I create a student, it's going to look something like this.
Yes, so student, and then you would put, yeah, the name and grade that you wanted, and then it should return that when you put a return statement in afterwards, basically, it should return, you know, both name and grade.
Close. We actually don't need a return statement anywhere here in this Thunder init method.
No, I meant in the Alice statement.
Yes, Tim, you're totally correct. And just to
Yeah.
add on to that, what happens here is this calls this init method, and I think like you were saying, it returns the instance of the class. It actually, you can think of it as it returns self for Alice.
Yep.
Right, and
exactly.
this is an instance
of the student class. Yeah,
exactly. Yeah, and if I do print Alice dot name or print Alice dot grade, and this notation called dot notation, that especially for those of you that have done more JavaScript looks familiar, is how we access instance attributes, right? These are both instance attributes because they exist on the instance of the class, right? If I did print student dot name, I'm not going to get anything. It doesn't exist on the class itself. We're going to learn a bit about class attributes in just a minute. And then we have this instance method here as well, which does nothing at the moment. But let's just say for the sake of argument, I'm going to have it do self.name. So that's hello. And then I could do print. I guess I don't need to print it because the say hello method already prints. And if we run this, we see we get Alice, we get 12, we get say hello. Right? And does someone want to take a crack at maybe describing like what is self again? Like why do we have to pass it here? What is it doing? How come for say hello, I pass self as an argument, but I don't have to pass it as an argument when I actually call the method? Len, yes, sir.
So in the init, and I said this in the chat too, init is basically initialization. So you're initializing the instance of the class, and self is, I don't know if it's really recursive, but it's just self-referential, right? It's very meta. So it's like saying my name, like this instance is Alice, and my name, my self name is Alice. So you have to put that in there so that you know to call yourself. Like I'm calling myself Lynn, right? It's that whole third person thing that Brian was talking about before. And now once you have it initialized, there's a student called Alice that other teachers and students can talk about and point at Alice or ask Alice for information and get the data and that from them from there after it's initialized.
Yeah, exactly. And just to play around with this, let's see what happens if we get rid of self from this say hello method and kind of watch what happens. So if I remove it from an argument here, first of all, this kind of makes sense that this is going to be a problem. So let's remove it from both. Well, now I've got this red squiggly saying name is not defined, but we should always be, VS Code is great, but these red squigglies and stuff, that's just VS Code making its best guess about stuff. You always want to run the code and have the running code be your source of truth. And we get an interesting error here. Say hello takes 0 positional arguments but one was given. But I didn't pass any arguments in to say hello. So what is the one argument that was passed in to say hello that this error message is talking about?
Name.
Close. It's not name.
Self,
Sorry?
self was passed in.
Self. Yes. And Cody, I saw your hand up as well. So indeed,
Oh, that
we-
was no, that was the answer.
perfect. Indeed, we do have name right here, right? And we want to access this instance attribute name. We want to be able to print it out. So it says Alice says hello, you know, and if we have Bob. And it would help if I spelled Bob correctly. You know, we want to be able to do Bob dot says hello too. I'll just comment that out for now so we don't get comments everywhere. But we didn't even get an error related to name. So what Python does, and the way the Python language works with classes, is that when you are calling an instance method on a class, Python passes in self. And I'm pretty darn sure, like, if we do a quick Google search here, Python, what is self, is in a
just did it.
dictionary. Self is it's a reference to the current instance of the class. I am pretty sure, I don't know if they're gonna have the answer here. I am pretty sure you can think of it almost as a dictionary if you want, but self refers to this instance of our class. And so whenever for every instance method that we create, the way Python works is it's always going to pass in under the hood, so to speak, without us having to do anything automatically. It's going to pass in self as an argument, right? So what Python actually does is it's probably, I don't know exactly how it does it. It probably looks something like this, where it actually passes in the instance itself. But that's why we need to have self here all the time, even if I'm not using it. Like I'll still get that same error. Oh, I will if I remove self. I'll still get that same error because Python is trying to pass in Alice, right? This instance. And we just use a variable with the special name self to represent that. And I saw a question or two.
I was just gonna make a statement.
Yeah.
Try to like understand it for myself. Like when you hover over itself, doesn't it give like like a pointer reference? Like it says like almost like a home location. Like this is my home address. Go back to that and then look at that information. And then if I want to like receive information or get information, like getters and setters, like that's what it knows to actually address. Is that kind of the way of thinking for that?
Yeah, I think you're on the right path. Like self really has everything attached to it, right? Like there's a reason I have to do self.name here. If I just did name and grade, this is not going to work. This method, sure, I'm creating these variables name or whatever I want to call it. But they're only created inside this method. Self is kind of like the collection box for the class instance. And in fact, I'll just maybe draw a quick little diagram here. Right, and all of these attributes, we are actually, that's why they're called instance attributes, right? We're adding these values onto the instance of the class. And indeed, this is even true of are instance methods. Though I don't have to do it explicitly. And so now by adding self, this method can access everything else on this instance. But let's say we want to do, say, hello, good morning. Well, what if I want to use the say hello method that I wrote? I can do it with self. So self is the container for all of our instance attributes and methods for like each individual instance. And I think I'll just pause there because I don't want to. I think I might end up making things more confusing. But does this help a bit to kind of like illustrate this and break it down a little more? We feeling okay on self, or like this is something that you all just need to we'll spend more time on.
I'm feeling okay, and the thing I put in the chat and I found online just says to me, the sentence that made it most sense to me was, without self, it would be impossible to differentiate between instance variables and class variables or methods. And once I read that, I was like, done, because we're doing the differences today, and self is for an instance, and no self is for a class.
Yeah,
I'm moving on. That's real.
Yeah.
That's me.
totally. I think that's a good way to describe it as well. So, this is a lot of the ground that we covered yesterday. Let's throw a couple more things in the mix. Let's make a couple getters and setters. Let's say that we want to have a student ID. But we want this ID to be, we don't want other programmers to directly say like modify this ID. I want to create, when I create a student for them to have an ID, to give them an ID, but I want to use getters and setters. So should I do this?
You should.
Well, I want to make this a little different. I'm going to just name this instance attribute with an underscore to indicate that we don't want to access it directly, right? And I'll use this property decorator to tell Python that this is a getter, because then I can go ahead, I can do like a setter, and we can do set ID. And let's maybe create a variable named new ID. And someone remind me, how do I use a decorator to make set ID a setter from Python's perspective to connect it to this getter that we created just now?
At get ID dot setter.
Exactly. We use the name of this getter method and then dot setter, and this is our other decorator. And let's just do a simple check. Can someone remind me maybe like how do I check that something's a number or not in Python?
You can do if. Oh, what I
Would
did.
it be?
I would
Is
do-
instance.
Yeah, is instance.
There is instance. There's also something, I think it's called is numeric. So we could do is instance to check for a number. Is numeric is a little more flexible because it will return, like if, say, I'm passing a number value as a string. Let's see what this does. Um. Okay, so we have a little bit of a design choice, right? Do we want this to be a number or a string? So I think what you all were saying, if type new ID equals int, we're gonna set the ID to the new ID. Let's be really flexible. Let's say if type new ID equals string and new ID is numeric. Let's set it as well. Otherwise, let's do we want to return something? We'll just print error not a valid ID. And let's go ahead and update this with student IDs. And let's see if this works. And we've got Alice and we've got Alice's ID. Right, and so now we've just created a getter and a setter. And then if I want to change Alice's ID, I can do alice.set ID equals 3 or whatever it is, or 4. Because when I'm using getters and setters, I don't have to call it with the parentheses like I do with the method. And I think the last thing I want to touch on real quick is, what if I just want to be able to print Alice and like see all her information? Right, this is not very useful. Can someone remind me, what do I need to add to this class? So if I want to print out the instance, I can see some interesting information.
String.
Yeah, let's go ahead and add a dunder string method. And what do we want to print out about Alice? Well, probably her name. How about just her name and her ID? And we can go ahead and we can use this getter that we created. And let's go ahead and add a little message here, because there's like grades, there's other information, just to make sure I know what it is.
Adam, what's the pipe do?
The pipe does absolutely nothing here. That's a great question. On the Linux command line, it does something. Here, it's just, I could
Splitting it
have
out.
done like some dashes. I just wanted a separator.
Okay, I was checking. I just want to make sure. Thank you.
Yeah, no, good question. So I know we kind of dove into some review here, but I hope that this covers stuff a bit more and refreshes ourselves a bit, and we get to see some getters and setters. Let's talk about class methods and class instances. Right, we've just talked a lot about instance attributes and instance methods. Let's talk about class methods versus instance methods. One good way to think about this is when you create a class, it's like a building. And you could think of it as like, say, the building for a company, if you want. It's probably easier to think of it maybe as an apartment building or something. Because in this apartment building, there's individual apartments, and each of them has the same layout. And so you could think of like each individual apartment as an instance of a class. But the apartment building has a lobby, right? The apartment building has a basement where the laundry is. It has the roof, the fire escape, and it has, I don't know, the apartment manager's office or something. So it has a couple rooms that are unique to the building. And that's kind of like what class attributes or class methods are. Like we can actually create some attributes that are for the class as a whole, that are not specific to Alice or Bob or Fido or Rover from yesterday with the dogs. So a class attribute or method can be accessed by all instances of the class. While like we saw and we've been seeing yesterday and today, instance attributes like, you know, Alice.names, Alice's name, or say hello can only be accessed by an individual instance. And if I change that, it's only going to change that instance. If I change Alice's ID or her name, it doesn't affect Bob. For a class attribute, if I change it, it affects all the instances of that class. So let's talk about this and let's write a little code. So we've added a bunch of stuff here to our student. We have name, we have grade, we have an ID, we have an F string, we have a getter and a setter for getting and setting ID, and we have an instance method to say hello and to say goodbye. And then down here we can see we've got Alice and we've got Bob. And let's just clear that up a little bit just to get rid of some noise. And I think I'll just comment this stuff out for the moment. What if I want to keep track of all the students? Well, one way to do it that we're familiar with, right, is I could say do all students and make it an empty list. And every time I add a student, I could do, what is it, all students append. I could print that out, right? And for reasons, actually, let me just go ahead and show all of you this. So notice that when I print out this list, I don't get nice information for Alice and Bob. I get that memory location stuff. But we have this dunder string method. Why isn't that being used? Well, for say objects and lists, Python doesn't use dunder string. It doesn't know how to use it. Dunder string is really specific to print. There's another method called REPR for represent. So dunder repr that Python uses when, say, I'm printing a list of students. And so now when I print that list of students, I can get some nice useful information. So these two are very similar. Only is used with print, basically used if and you know, doesn't handle nesting. Used if, you know, object is nested in a list or something. And in fact, if I had to choose one, if you just write repr, it should work. Like if we go ahead and we print Alice, we see that this represent method gets used as well. So my preference is just to write this. If you want like more detailed information when you print someone out, you can put it in the string. But we've got a list of all students. This is fine. Depending on how we design our program, maybe this is the way we want to do this. But maybe, you know, I am importing my program and I have a lot of different files. And can someone remind me, how do I import the student class that I created into this other file?
From practice, import student.
Yeah, exactly. And just to give you all reference of where we are, I put the class definition here in practice PY, and in the same directory, there's also runner PY. So these are at the same level. Right, because the more code we write, this is probably what we're going to end up doing. And if I'm importing and using students all over the place, maybe I decide I really want to always have that list of all the students. So maybe for organizational reasons, maybe for other reasons, I'd really like the student class itself to actually have the list of all the students. And this is where class attributes come in. And normally you'll put them up top before the dunder init method. I think that's sort of the convention. Someone can correct me if I'm wrong. I'm going to create a class attribute, all students. And let me go ahead and do a little bit of a split here. And close out everything else that we don't need. And let's put all this stuff down here because we don't care about it right now. So, and I'll put this stuff even further down because we care about it even less. Check this out. This is, let me just go ahead and comment all this stuff out and bring Alice and Bob back to the top. And apologies that I'm jumping around a bit right now. I'll try to make sure I don't do too much jumping around as I'm writing code. And let's just add a quick print statement here just to say all students, just so we can see what's going on. And so somewhere I'm still printing out Alice.
In line 4, you have Alice, or where should we say Bob?
Oh, thank you so much. Yes, that should totally be Bob. But right here, we see all students for this print statement, and then we see an empty list from this class attribute that we added. Right, and if I wanted to, I could put stuff in here. If I wanted to, I could append something to it just like any other list. Right, and let's print that out and see what happens. So this is kind of useful because I can have an attribute on my class that then wherever I import this class, it will be there, and there's only one list, right? It doesn't matter how many individual students, how many instances I create. It's the class itself that actually holds this list. Anyone have any thoughts as to how I can get Alice and Bob into the list of all students so we can actually have some students in here?
You just append it in line 7.
Totally. Let's go ahead and let's add Alice. Let's add Bob. And let's see what happens. And now indeed, I do have Alice and Bob in my list of all students. And I do want to get rid of those print statements just so they're not cluttering stuff up. And Eric, yes, sir. I see a question.
I was curious if it'd be possible to handle that in the init method itself. So every time you added a student, it would automatically just append that list with the new student's name.
That is a great idea, and it absolutely is. And in fact, let's go ahead and do that now. Add newly created student instance, right? To all students. So here, I don't do self all students. I do student all students because it's part of the class.
Hmm.
And I believe I have that syntax right. If I have it wrong, we'll find out in just a moment when we run this. And what should I pass in here as the argument? Any thoughts?
Probably
The
self.
self.
Love it. Love it. Great minds. Great minds think alike. Self. Because self holds that instance. Right? Inside the code for our class, self is how we refer to the actual instance itself. And let's get rid of this. Let's not do it this way. Let's see if this works. If now when I create Alice and Bob, they get added to all students, and then that's printed out. Awesome. Right? Lo and behold, we got it working. We got some good stuff. It's a class attribute. So if I did self, I'm probably gonna get some sort of error here. I'm not exactly sure what's gonna happen. I guess that works. I wouldn't trust it, to be honest. I'm pretty darn sure we want this to be the class name right there. Holly, yes. Or
Yeah,
oh no,
I'm sorry.
Murad.
Yeah, I'm sorry.
No,
Yeah,
you're good.
Why we now, when we add attribute to the class, right? We say self dot the attribute, okay, equal the attribute name. Why we start here with student? We didn't start with self.
Oh, right here. I am actually looking that up right now to double check that give me 1 sec to make sure I didn't get confused about anything. I'm pretty sure that it's that we don't want to that using self doesn't quite work. And does something else like other than what we want. Because I did try it out just now here like this, and to be honest, I was a little surprised that that did anything. Let me actually just double check, in fact, our own stuff. Yeah, because we'll go over this, but let's see. Python access class attribute using self, because I actually would have expected that to cause an error. But maybe there's a bit of sort of like Python-y stuff here that I'm missing. I guess you actually can access the class variable with self. I wouldn't recommend it. I don't think I need to. Okay, and in fact, here's the answer. Python first looks in the object. If it's not there, it looks in the class. So it actually does work, but we don't want to do it. So this works you can access this class attribute this way. This is the right way to do it though, where you use the name of the class because this belongs to the class. Because if for some reason we had self.allStudents, and let's just make this up. Let's just say for the sake of argument, we had an instance attribute that had the same name of a class attribute. Well, now all of a sudden, we're adding this to our instance attribute. And right here on line 7, where we're trying to print out that class attribute all students, I'm not seeing what I want to see in there. And in fact, let me get rid of that placeholder stuff. Right, so this is the danger. Like, Python looks first for an instance attribute when we're using self dot something. And if it doesn't find it, it looks at the class attributes. But this is you will end up causing problems and bugs that are hard to find. And if I'm a programmer looking at someone else's code, I cannot tell if this is an instance attribute or a class attribute. So since all students is a list that belongs to the class student, it's a class attribute. Let's use the class name dot the attribute name, because this way, as another programmer, I look at this, I see, oh, this isn't an instance attribute, right? Like Alice does not have a list of all students. Though it might actually print something. Yeah, and in fact, it's a little confusing because here we can access the class attribute off of the instance, because Python will do that for us. Like, note if I do Alice.allStudents down here, or actually after we've added Bob is already in there. So this does give us the list of all students. But really the problem here is confusion for other programmers. Like if I look at this code, how can I tell that Alice.allStudents that this is a class attribute? So just as a convention, as a way of avoiding potential errors and confusion, as a way of avoiding naming conflicts for class attributes, unless there's a really specific reason, access it off of the class like this, like student.allStudents, and like we do here, right? Because this list is connected to the student class. To go back into the diagram, if we've got the apartment building, all students is like the main lobby, right? It's shared by everyone in all the apartments in the building. Does that help a bit, Murad, to answer your question?
Yes, sir. So that's now the instance attribute is attribute shared by all the users or the students, right?
Yes, sir. Exactly.
Not
Yes.
not so when we make like self dot all students, that will be just for one instance, for one object.
Yeah, exactly.
Okay,
Like,
so when we use, or how can I, what the advantage from making the instance, student instance, or the uses for this one?
yeah, like what's the advantage of creating a class attribute named all students and
Not
having it?
not class attribute, the instance, the student instance, the
Oh, you
the
mean
class
like
instance.
Alice and Bob?
When we create the student dot all student dot append self.
Got it. So the advantage of doing this is whenever I create a student like Alice, Bob, or let's make another student named Carol. And everyone here is going to be in grade 12. Because in the init method for creating a student, self refers to Carol, right? This new student that I'm creating. And then I add Carol to this list of all students. And that's a class attribute that's connected to the student class. And now every time I create a new student, they get added to this, and I can modify student information to my heart's content, but I'll always have a list of all the students right here. And if I go ahead and I run this, I can see now I've got Alice, Bob, and Carol. Earl John, yes, sir.
Just want to clarify something. So is the dunder rep the one getting appended to the all student, or is it the dunder string?
Oh, both of these methods exist for all students. So Alice, Bob, and Carol have that for the student class. It's an interesting question. I don't know if we have one. If we do print student, let's see what happens. Yeah, so these are both instance methods. They are for individual students, for instances of our student class. They're not for the class itself. I'd have to look up how. I'm sure there is a way to write a dunder string or like a repper method for the class. We haven't gotten into class methods, but there are ways to write methods for the class, and that's probably how you do it.
Okay.
Yeah,
Thank you.
remind me, and in the second part of the lecture, we'll circle back to that one.
Okay.
Cool. So I have one more question here, which is so we've seen how to create students. We've seen how to create a class attribute, which belongs to the student class. We've seen that there's multiple ways to access this class attribute, but again, do it off of the class like this. Don't do this because it will become confusing and it can cause potential issues if you have two things with the same name, because this list really belongs to the class as a whole. And I think the last thing I want to cover, and maybe after sort of the work time, we can do a little diagramming and tail draw to go over this stuff. But the one bit I want to build is with the ID and doing a little bit more with the ID. And Brandon, yes, sir, I saw you had a question as well.
So my question is for line 13. So we're appending self to all students, but what happens when we, like, let's say we want to set name to something else, or we want to advance the student to the next grade?
Yeah,
I'm not understanding how the setter is going to update all students to reflect the change.
great question. The setter is only for an individual student. It's for an instance, right? Or any attribute. So let's take Carol.
So
Let's say,
you're saying after you append it inside of the constructor, you can't edit it anymore without explicitly declaring it, declaring the update.
let me write this code and run it, and then let's come back to your question, because I think that might help, and also it'll help me make sure I'm understanding the question.
Okay.
So I think the point you raised was like, all right, I add these students to this list of all students. What happens if Carol changes a grade? What happens if we want to use the ID setter that we did to change Carol's ID? And I'm just choosing some, I'm just choosing some big numbers here, so it'll be easy to see.
Mhm.
Oh, I don't want to go all the way down. I apologize. So let's just do a little before and after and see what happens.
Interesting.
So we're able to change individual student information, instances of a class, perfectly fine, right? Because we have, just like if you had a normal list of stuff, you know, like if I had a list of students here, and then I change this stuff, and then I print out the list of students, I'm gonna see, right, we've changed the value of the thing in that list.
Gotcha. So it's intrinsically tied together.
Yeah, I think the way to think about it is all these instance methods are for individual instances. And we'll go ahead and change them, right? And the class method, it's connected to the class, but at the end of the day, this is just a list. There's nothing magical about the list. So we still have stuff in the list, and we can change that stuff in the list the same way we would change stuff in any other list.
Is that
And oh yeah,
is that because so the instance is always gonna be at a certain point in memory? And that's why it's able to do it, because it always knows the reference is to that point in memory?
yeah, exactly. Like Alice,
Okay,
Bob, and Carol, these are references to like where
right,
the actual data lives in memory.
right, and okay, that's all making a lot more sense now then.
Got it. Yeah, I see what you're saying. Because like if I had, you know, 4, 12, 99, right, I actually would have to maybe like get rid or like change the element. But no, like most stuff with Python, I think is passed by reference. I mean, you know, if I have x equals 1, 2, and y, or y equals 4 and z equals 5.
Well, I was thinking that references never really made too much sense to me, because it was just like, it works, but now it makes a little bit more sense.
Yeah. Oh, and in fact, we can see that it doesn't work right here where I print out all the students. Yeah, that's exactly it. Like if I look at this list right here of these little variables x, y, and z, 2, 4, and 5, I change the value of y. I print out the list of all students. It's still 2,
Right.
4, and 5.
Right,
Because when we created this list, Python actually stuck the value of y in
right,
there. So in that list is actually the value 4, as opposed to with,
the class instances we're putting the reference in there and then
yeah,
changing the actual student through the getter and setter methods.
yeah, exactly.
Okay,
Exactly.
interesting.
With dictionaries, with lists, with instances of classes, it's going to be passed by reference. So if I stick these students in a list, under the hood, the list holds like a pointer to where they live in memory, which means I can change the student and the value changes in the list.
Gotcha. Thank you so much for that.
Totally. Yeah, great question. Let's tackle one more thing, and then we can take a break and do some cooking ourselves with the recipe. I don't want to have to create the ID for each student. It's easy to mess up. I want this to be an auto incrementing ID. I want it to happen automatically. Any thoughts how I could maybe use a class attribute and this init method so that every student has an ID and the ID is always like increased by 1 for each new student?
You do a class variable. Oh, I was gonna raise my hand first.
Oh, go for it, Brandon.
You do a class variable that says total students. You could set it to 0. And then in the init function or the init method, you would just increment, you would do student dot
You were saying in the init method, do what?
Yeah, right below student dot all, yeah. Below that you do student dot total students plus equals 1.
And then what do I do to actually set the ID?
That would be, I mean, if you wanted to start at 0, you could have that equal to student dot total students, or you could have it as +1.
Hold on. And what I would recommend here is I think it's a good idea to think about keeping track of the total number of students. We can actually get that from the length of this list. It's okay, and in fact, I would encourage like to name this a different variable, like just maybe ID counter or something like that, or next ID. That if I'm looking at this, because if I'm looking at this as a program and I see total students, I have to dig into the code to see, oh, we're actually using this for student IDs. But if I see like ID counter, I know this is somehow related to IDs. And then also we can have it start at 1. Since as you pointed out, we might not want the student IDs to start at 0. And so then that solves that problem for us as well. And we can just look at the length of the all students list to get the total number of students. And so now I
Wouldn't
think,
that,
yes,
wouldn't that cause an issue down the road though? Like what if you removed a student and then let's say you removed a student and then in the future wanted to add a new student and you took the length and there was a conflict with the keys, with the IDs.
the IDs don't have to match up to the length. That we're not necessarily going to guarantee that. Like that's pretty normal. Where like in real world data, if you grab a list of stuff, you might see like IDs jump from like 2 to 5. The ID's only job is to be unique at the end of the day. That's a good thought though. I did do something wrong here because I'm not seeing the IDs increment the way I thought I would. So I think there's some sort of silly mistake that I made. And I'm also seeing error not a valid ID. Oh, probably from, oh, that shouldn't do it. I would have thought that should work. Alice's ID 1. Oh, I'm so sorry, folks. That did work. I just got confused by my own print message, which is honestly a more common than you think. Because I was looking at the list of all students, and I was just having a hard time reading it. But we've got Alice with ID of 1, Bob with ID of 2, Carol with ID of 3. Murad, yes, sir.
Yes, sir. So now to create a new instance, okay, create student instance, okay, like the new one, Carol. We use the class name dot all the student, the list that we created to add to it the new instance. But how to pass this instance? Just write down the new name and how did you pass it?
Do you mean for creating another student like Alice, Bob, or Carol, or if I
Yeah,
want to
yeah.
grab a student from the list?
No, not grab student from this to add this student. Yeah, you just here like the Carol wasn't here.
Got it. Yeah, exactly. So like if we add another student, David,
Yeah.
and let's actually have David be in grade 9 just for fun. Let me go ahead and walk through what's happening when we run this code. And then I think that's the perfect time to break, and then you all can get a bit of work time. And then when we come back, we'll look at class methods, because there's a couple different flavors of class methods. And I think this is a great wrapping up point. So I run runner.py, and I apologize because I just don't use breakpoints a lot, so I I don't feel fluent enough with it to use it to walk through this. Otherwise, it would be a great tool, but I will just walk through it manually and talk through what's happening. So let's, for the sake of argument, let's comment everything else out. So all we're looking at right now is David. So I run runner py. Line 1, it imports the student class. Line 6, it calls the init method for this class. So in the flow of execution, Python hops over here to line 7 in the student class where we call init, and it's passing in as arguments these two values, David and 9. Right? So we have David, excuse me, and 9. And going through this, right, this is now David, and this is now 9. And we're just going, right, and Python's running this init method line by line. And then when it gets here, it says, oh, okay, I need to look on the class for a class attribute named ID counter. Let me go ahead and look at that. Well, let's just say for the sake of argument, David is our very first student. So the value of this is 1. And it keeps on going. And then here, Python says, oh, I need to look for a list named all students, but it belongs to the student class. Here it is. Let me append that to this list. Right, so this list now has I'm just going to do David in all caps to indicate that that is not a string, that's the instance, right? You can think of it, it's passed in self is really what it's done. I'm just not sure of the best way to represent that. And now we've incremented ID counter here on line 15. So now student dot ID counter is 2. And in fact, let's print all students. Let's print student dot ID counter. And let's do a nice little before and after. And we can watch this run. So as I'm running my code, in the very beginning, this list all students that belongs to this class has nothing in it. And the ID is set to 1 because that's what we've hard coded here. Then I create this student that I've named David. And what ends up happening is this instance of the student class, we have 2 references to it now. And in fact, let me make a little diagram because this is, I think, actually the perfect point for a diagram. Let's say that we have here, right? Let's just say computer memory, and I'll make this a bunch of boxes since everyone loves boxes. And up here, we've got David equals student David 9. Let's make this red. And then we've also got, you know, student dot all students, which has David in it, right? And this has happened and so we run this code, and then we've got these 2 variables. We've walked through how when I create this student, it's gotten added to the list. And this has returned, and maybe let's make this green. This has returned that student. So what this actually does is it creates in, let's just put this maybe like here. It's created an instance of the student class that lives somewhere in memory, and we now have two different variables that point to it. Right? I've got a reference to it in my list, and I've got David itself. Because as you point out, Murad, here, student, this returns something. David now has that student, but we've also added them into the list over here. And the way that that works is because the actual information lives in one spot. And then we have two references to it in our code. And that is maybe getting into the weeds a little bit. So I think this is probably a good time for me to pause. But I hope that illustrates it a little bit, and that walking through this was helpful, and to kind of see line by line what happens. And so now, you know, if we add another student, what happens? Well, this calls our constructor. This is now Frank, who's in grade 3. This student counter is already 1. It's been incremented to 2 from when we created David, so ID is 2. We've now got Frank in here as well, and this gets incremented to 3. Right, and so then this returns a reference to where Frank lives in memory, and we've got Frank in the list. Eric, yes, sir.
So if you were to remove the dunder string and dunder wrapper methods, would printing all students just print a list of memory addresses?
Great question. That is exactly what would happen. And in fact, we only need to remove the dunder wrapper method. And actually, that's a great idea, because I think that's a good way to illustrate this. Right, this is the list of all students. And this is where that actual instance of the student class lives in memory. And the list just holds a pointer to it. And let me go ahead, and I think maybe a good way to do this is we can add Frank right here. Right, and here's Frank, who is in grade 3. And let's maybe, the lines are going to cross a little bit. I apologize, folks. But there's Frank, and here we have Frank as well. I'm not sure if this illustration helps or hurts, but hopefully it makes a little sense. Yeah, so the main takeaway here is lists, dictionaries, instances of classes. What is held is like a reference to where the actual thing lives. And most of the time that doesn't matter, but as Mordad pointed out, you know, if we were just dealing with, say, an integer, we would end up possibly, or as Brandon pointed out, like, what's going on here? Do we have like multiple copies of the same thing? And the answer is no, because we have multiple references to the same thing. So I can still change this from any of these other variables, and then when it's changed for all of them. Or a better way to put it is, if I change this, these just refer to it where it is in memory. And I do think I'm probably getting off the thread a bit, and I do want to pause so that we can have a break and work time. So let me just pause here and quickly show the assignment that it'd be good for you all to work on for about the next 30-40 minutes. And then when we come back, we'll look at class methods. I'm happy to chat more with anyone who wants to about this stuff later. It doesn't have an immediate impact on writing code, though I think kind of depending on your learning style, it can be valuable for understanding. we didn't talk a ton about when to use class attributes or when to use instance attributes. It's relatively straightforward. As we saw here with the all students list, class attributes are good for shared information. They're also good for constants. There can be some memory efficiency. It really depends. Constants and shared information are really the two big use cases. Try to organize and sort of encapsulate your data, whether you're using an instance attribute or a class attribute. Keep it simple. The answer is usually going to be an instance attribute, especially if the data is going to change between objects. Don't overcomplicate stuff. I think that's always the golden rule is don't overcomplicate stuff. This last point is a little more subtle about global state with class attributes, so I think I'll just stick over it. Just try to think about when you create classes, what is the job of this class? And whether it's an instance attribute or a class attribute, like, is that part of the job of this class or does it belong somewhere else? So the assignment that I'd like you all to tackle over the next 30 to 40 minutes is writing an object-oriented car management system. And we're going to want you to make a class, and we're going to want you to use some class attributes to keep track of all the cars. And we're going to want you to make a bunch of instance attributes. Note that these are named with an underscore, indicating that they should be private. So you might have to, so you probably should be making getters and setters for each of them. And we'd like you to write a terminal application so that you can do have some interactivity here to add cards and stuff like that. And actually, I should merge this pull request that Rich did, which is awesome. And if GitHub would just, I will merge the pull request momentarily, and then we will have tests for it. But that's the assignment, and I would say let's do this. If you want to work in a team, go for it. If you want to work on it individually, that's okay too. I'm just going to leave it up to all of you, because some people I know like to you like to put your heads together. Other folks need to like take some time for it to be absorbed and want to dig into it on their own. And then we will reconvene on the hour at 11 Central to look at class, different kinds of class methods. And that is sort of the intro to class attributes. Let me go ahead and stop the recording. All right, so did folks get a little bit of hands-on time with that first assignment to make some class attributes? Yes, no, maybe. Cool. And Brandon, yeah, Brandon Y, I would love for you to demo a little bit of code, and thank you in advance for letting me put you on the spot. We totally get that this is work in progress. WIP code.
Okay, so when I was making my car manager, I wanted the user to be able to continually input a new car, and because of that, I was confused on how to keep making variables to store the new instances I made. So I kept looking it up. I was like, what if I just use a for loop to make unique variables? But instead of doing that, I realized that whenever you make a new instance, and I did it up here, I did the thing where you would append self into all cars, which after doing some type checking, after making instances and setting them to variables, I realized that when you append self into all cars, this self is equivalent to when you set like the variable. So it's equivalent to like these are all name, and then you do car manager, and then you put the whatever in here. So what it prints out is, I think it's car manager object. And whenever you do this in the below code, it basically you can access this exact thing by just iterating through all cars, which I have in a for loop here for view all cars. You can do a for loop to iterate through all the cars you've stored in car manager as the class attribute. And you can do, I made a bunch of getters. I didn't get the time to make any setters, but
It's
I made
okay.
a bunch of,
Sometimes it's totally fine. Sometimes you might have a getter, but maybe you don't need a setter.
so I have 3 sample cars here that I didn't put much information in, so it's gonna put none for most of them. But if I run this code, it's going to I have it as view all cars default because I was testing that. So so we're in for I in car manager that all cars. So I stored all of these instances in all cars. So now when I iterate through all cars, the I is going to be the individual instance that I've stored. So for the first instance, which I've stored a Honda CRV, it prints out the information if I get all of it for that instance. And then if I press N to go to the next iteration, it should take us to the next object I've stored in the all cars list, which is a Toyota, no model. And then I have one more, and if I press N, it should be a Ford. And yeah, it's just really nice understanding that you can just store all the instances in a list and access them without having to make a bunch of variables. Because I know when we initialized, we would store it into a variable, and I was just confused on how you would access every individual instance if it was user input. Because if I didn't, if I had a, what's it called? If I had to keep making new cars, I wouldn't be able to write into code it, and it wouldn't be very dynamic. So now that you have user input, I haven't I haven't like put all of this together yet, but theoretically, if I had add car and I had the user make a new car, then I could access that car with this as well.
Nice. That's awesome, man. Yeah, that was a great walkthrough. If you don't mind for my sanity, just put like an empty line below line 50. Or oh, I see, that's part of a string. Never mind.
Yes.
Got it. With doc strings, I think you can put it on multiple lines. I see what you did there. Yeah, man, this is awesome. Do folks have any questions for Brandon or about this code?
Cody?
Yeah, what is the difference between what you did and then the repr? I know the repr prints out, is it just yours is more interactive?
I think the repr, you just put it in the class and you can print it out that way, but I guess I wanted it to look like this. I don't know. You could put it in repr, I think.
Okay, yeah, thanks. That's the first time I've seen a repr, and I think your way it's more interactive, but that makes sense. Thanks, dude.
I think with repr it'd be the exact same. You would just do for I, and then you would do I dot or however you access repr or repr I
Yeah,
instead of
you
all of
could.
this. Yeah.
Oh, okay, I see what you did. Okay, I got you.
Yeah, with repr, the other thing to bear in mind with repr is like anytime your instance is being like turned into a string anywhere, repr is used. So if you have something that you want a little more like rich or detailed, repr might not be the right place for it. Yeah, this is great, Brandon. Thank you. And any other questions, thoughts, feedback? And is there, oh, sorry, go ahead.
Does she have a question?
Yeah, I do.
Yeah.
I'm kind of confused. I know that you, Adam, kind of talked about it like earlier. The underscore in front of, like, let's say, for example, on line 37, services. What's the difference between having the underscore or just calling it services?
Go for it,
You
Brandon.
Okay, so with services, I didn't want this this class attribute to be modified directly, and ideally I would have a setter to be able to set services, but I didn't get to do that. But this underscore basically means do not modify the class attribute directly through whatever variable you set the car object to dot underscore services. So don't do that. Use the setter instead.
And Brandon, that was a great breakdown. The only thing I'm going to throw into the mix is self dot underscore services is an instance attribute.
Ah, yes, yes.
Yeah, which I know the jargon is a lot, and normally I'm a little loose with jargon, but just because we're learning it today, I just wanted to say that explicitly. Otherwise, you hit the nail on the head. The underscore indicates to other programmers, don't modify this attribute directly, you should use a setter. And don't access it directly, you should use its getter.
Any further questions?
Awesome, man. Love it. Yeah, great demo, and thank you. Would anyone else like to maybe demo or show some code they were working on during the work time?
I would like to nominate Brandon N to demo his code because I like the way he used switch case statements for his menu.
Okay. It's not done, but
Awesome, go for it.
so pretty much everything for the most part looks the same as Brandon's, except when you get down here, and again, it's not done, please don't judge me. Basically, I have a function menu, which just, basically gives you a list of choices that you can choose from the terminal. And then here, I do have it set to pass, but if user's choice is equal to case 1, then I would run Brandon's function for add a car. And then it would populate with all the user input. Same thing with view cars, it would populate view car, and then it would, for the rest of the cases, it would do the same. But basically you just enter your choice here and it would move on to the next step in the program.
Yeah, I know it wasn't bad. I just thought it was a really clean way of using the functionality for the menu, and I didn't think of it
Oh,
at first
gotcha.
until I saw his.
Nice, that's awesome.
All right.
Thank you, Brandon. All right, let me go ahead and share my screen, and we're gonna dive into, and let's hop over here where we need to be, and we are gonna dive into class methods and static methods. I'm just gonna do a little cleanup here and get rid of the things that we don't need. And let me just make a new directory here real quick. Or let's just and we'll just write some code in here. So, and let me hop back so I can have our curriculum up as a reference. So we've learned about class attributes. And in fact, let me go ahead and write this circle class that we see here in the curriculum. I'm going to make a little bit of a modification. We're going to have an init method, right, with self that references the instance, this particular circle we're going to create, and the radius of the circle that we want to make. And I'm not going to worry about getters and setters for the moment. I'm going to keep it simple. I don't really need a getter or a setter for the circle's radius either. And let's make an instance method called calculate area. And we're going to add in the value of pi, 3.14159. times the radius of our circle. And these two asterisks together is how you square something. So this is, pi times radius raised to the second power pi r squared. And so, let's just maybe make a circle named my circle. And I don't know, let's give it a radius of 3, and let's print the area of my circle. And we get a number back, and I'm trusting that Python did this arithmetic correctly. I'm sure it did. And we can calculate the area of a circle. And, let's make another circle. And this one's going to have a radius of 5. And let's just print the area of your circle. So just to get the ball rolling, if I look at this, it makes sense that these two circles will have different radiuses and that this should be an instance attribute, right? This is unique to the instance, right? A circle like has a radius of 3. This circle has a radius of 5. Pi is not unique to the instance. All circles have a value of 3.14159 for pi. So just to demonstrate another use case of class attributes, we can make pi a class attribute. And excuse me, I just had to grab a glass of water there. And let's go ahead and make pi a class attribute. Maybe I'm gonna, just for convention, since this is a constant value that'll never change, I'll name the attribute in all caps, which is a naming convention that you'll see programmers use for constants. And then can someone tell me over here, how would I now use this class attribute pi to calculate the area?
Circle.pi.
Yeah, thank you. We learned, and actually it was new to me. Yes, this will work in Python. It will access the class attribute. It is a bad idea because it makes the code harder to read, and there's potential naming conflicts. And now calculate area should work. And the nice thing is too, I have a canonical place in my code where I can go to see the value of pi. Because maybe I need it somewhere else for some reason in my code. Maybe I'm doing more geometry or something like that. And so for the moment, I've decided that having it on the instance of that circle class is useful. There are other ways to organize my code, but this is certainly a reasonable way. Let's say that we create another shape, a rectangle. And I'll scroll down here a bit and let me go ahead and comment all this stuff out just so that we don't get a lot of print statements. And let's give us a little room here. And let's make a rectangle class. And let's add a init method with self, right? So that when we create a new instance of a rectangle, we can refer to itself. And a rectangle needs a width and a height. And again, I'm not going to worry too much about getters or setters right now, just as we're introducing these concepts. And I might not really want or need a getter or setter for these anyway. And I can do, like rectangle, my rectangle equals rectangle of an area of 20. And we can go ahead and let's do maybe just like a calculate area function just for fun. Right, and with time height gives us the area. I can calculate the area of my rectangle. Let's say I want to make a square. Well, I know that a square is just a special kind of rectangle where each side has the same length. So let's make a really big square. The area formula should work the same. It'd give me 64. And we're doing great. Well, you know, I might want to create a lot of rectangles and a lot of squares. You know, maybe I'm making another square. And your square is going to be even bigger. It's going to be 12 by 12. But let's say I make a typo and I accidentally put 13 instead of 12. And I'm working on, one of our coding assignments for the day. And I run my code. And we don't have tests for it. Or maybe we do, but I've been coding all day and it's like 12 in the morning and I can't find, hopefully no one's coding at midnight, though I know a lot of people will be. And I just can't find this error for the life of me. And then finally, after like 30 minutes, I'm like, oh my God, I just needed to make that 12. Well, since these sides are the same, I can write a method to do this for me. I can make my life easier. Like instead of doing it this way, I could do def create square, right? And let's just pass in length maybe as an argument, and then return rectangle. There's probably a shorter way to express this, but I'm just going to call it side length. Side length. Side length. And this was a square of 8, and your square is a square of 12. And now I'll never make that mistake again. I've successfully used code to make my life easier and make the computer do the work. And this is really nice to have. In fact, it's so nice to have that I want this to be kind of part of my rectangle class. So I don't have to import a second method. So as I change code, if stuff gets more complicated down the line, I don't have to add more stuff. Well, that's where class methods come in. And I can add this as a method here. And let's put it here. You often see these at the top. And let's see. With class methods, they're a little different because we don't want to pass in self, because self is for a particular instance, but this is sort of like a helper for the class for us to create squares. So the way you use a class method is instead of self, you pass in the first argument is named CLS. And then over here, instead of saying rectangle, I can just say CLS. And CLS is short for class. And just like self is a placeholder for a particular instance of this class that we're creating, class is a placeholder for the class definition itself. I shouldn't say itself, so that's a little confusing. It's a placeholder for the class definition instead of self. And so now I should be able to do rectangle.create square and rectangle.create square, except this is going to see, as we're all going to see in just a moment, this should be throwing us a little error. And indeed, we do get an error. Rectangle creates square missing one required positional argument side length. Now that's a little weird because I've got it here and I've got it here. So what's going on? And what's going on is Python doesn't know that this is a class method, that instead of self, it should be passing in class as the first argument. I might have made another mistake somewhere, but I don't think so. We'll find out in a minute. The main thing I want to demonstrate here is in order to use a class method, we need to use a decorator. And the name of that decorator is class method. Right, and that decorator adds some extra logic, right? Because a decorator does some extra stuff before the function, the method itself runs. And that tells Python, all right, grab this specific class, a class definition, and pass it in here as the first argument. And now, fingers crossed, I should be able to run this and without an error. And now this is really nice because now I can import rectangle anywhere and do rectangle create square. And when another programmer is looking at my code, they only have to look at this one class definition to see all of this related logic for it in one spot. And if for some reason, I don't know why, but if I ever change the class name, it's not hard-coded in here, which is sort of a nice to have. There's a couple ins and outs with that as we get into inheritance. But it's sort of a nice icing on the cake. So that's the basic idea of a class method, that an instance method is used on an instance of a class, right? Like my square, this particular instance will calculate the area. A class method is used on the class itself. And normally, this is what we use class methods for. You're not going to use them a ton. Instance methods are sort of your go-to. Creating a sort of alternate init method like this is a really classic use case for a class method, and probably what you'll be doing most of the time when you use it. Brandon, yes, sir.
Never mind.
Oh, okay, awesome. But this is actually a perfect point to pause and check in and see what questions folks have or what's on people's minds. How are people feeling about this idea of a class method?
Can you repeat that last part of the perfect use case for the class method? You said was making a class init method?
Yeah, absolutely. Like the init method, you'll often hear it called the constructor, right? It's how we construct, we create an instance of a class. Well, what we're really doing here is creating like an alternative constructor, because a square is a special category of rectangle. And I want to, automate that process of creating squares so I don't make silly typos. So I don't want to, I want to keep this init method flexible because I want to be able to make rectangles with it. But I also want to be able to create squares. And that's what this class method lets us do. It's another way of creating a particular kind of rectangle. It's like an alternative constructor. Does that help a bit?
Yes, thank you.
Yeah, great question. Brandon, yes, sir.
Could we actually, do we have time to walk through that? Because I would like to see a constructor with no parameters and then using the class method constructor to add an instance, like a new instance.
We can. I'm not sure if like our init has no parameters. I'm not sure how far we'll be able to go with it, if I'm understanding.
Well, you're saying that we could use the class method as a separate constructor.
Ah, I see your point.
So we could add additional parameters there, right?
Great question. And actually, I should probably, yeah, I'm really glad you asked that because I should probably clarify a bit. And let's just walk through what happens here when I run my code and we get to line 34. And this create squared class method is called. Python hops over here to the class method. It passes in 8 as an argument. If my thingamajiggy would, there we go. Right, 8 is passed in. Here, CLS, what this is, and let me make this bigger. This calls rectangle 8 is what happens here. This calls this init method right here.
Okay, gotcha.
Yeah, yeah, I see exactly where you were going. So you could put stuff in here, but because sort of the way we're using this here, what this does is it actually calls this init method. It wouldn't make a lot of sense.
Gotcha, okay.
Yeah. You know what you can, I mean, you can also in here, if we had some class attribute like I'm trying to think of what a good, I'm just gonna make something up. I can access class attributes using this CLS placeholder as well, right? And sometimes that can be useful also. But using it this way, we're calling the init method of the class.
Okay.
Yeah, great question. Thank you for asking. What else is on people's minds, or what other questions do folks kind of have around this? Let's make maybe like a triangle. And then I think we can take a look at static methods, which I think will be good. And I could use a little help from all of you in creating our triangle. And in fact, I'm probably going to need a little help in like the triangle area formulas. And can someone tell me, like, what are our different kinds of triangles that we might want to be making here that we can
Acute,
use some class
obtuse.
constructors for?
Isosceles.
Yeah. What else?
Right.
Love it. What else?
Always gotta have a cute triangle.
A what triangle?
Acute.
An acute triangle. Is that where it's less
Acute's the
than
small
90?
angle, yeah. And then
The biggest.
obtuse is larger.
Yeah. Okay. Is there a way for us to automatically calculate that? I'll put that down with a question mark.
Yeah, there's definitely a formula for
Got it. Okay.
it out.
I may call you on that one then.
We should be able to.
There's one other kind of triangle I'm thinking of that's, I think, particularly easy to construct.
Equilateral.
Yeah, totally. And actually, I could use some help from you all in what the heck are the arguments that we're going to pass to create our triangle. What should we pass in to create it? Like, are we talking angles? Are we talking side length? What do we think?
I think we should probably be going for length of the sides first, because we can calculate all of this just off of that.
Yeah, I think that makes sense. And to be honest, I'm kind of thinking this through as well. So if someone has a good idea, definitely let me know.
If you're thinking about the trig though, you need 3 sides or you need 3 pieces of information. 2 sides and 1 angle, 2 angles and 1 side. And so like you can ask for all 6 of those things, like all 3 sides or all 3 angles. And then at the very beginning, when you're setting them, you would have to check what's given, because any of your math is going to need or like all 3 of the things, right? If you have all 3 of the stuff, you can do things too.
If we have all 3 side lengths, you mean?
Yeah, because A plus B equals C, or there's there's those kind of equations, but you can do things with the angles too. For this right now that I'm talking this out, and I apologize to go all the way, starting with the sides is probably the best way for this example right now.
Yeah, I agree. And to be honest, I'm thinking this through as we go as well. I was like, triangle, perfect, because we can do equilateral. I hadn't even actually thought about checking for validity, and I think that's a great idea, but I think all 3 sides is a good starting point. And this is also a good chance we can kind of, as a group, kind of go through the process of like program design, right? Like when I have a problem, how do I design a solution for that problem, to model that problem, write a little algorithm to solve that problem? So we got to check that all 3 triangle sides are valid. I know we're gonna pass in 3 sides as an argument. I want some sort of diagram I can use for my own sanity. So when I'm talking about sides like A, B, and C, I can know what the heck, which side is which. So I'm gonna make like the world's worst triangle diagram here. It's gonna look something like that. Actually, that turned out way better than I thought it would. I'm not gonna lie.
That's a nice triangle.
Yeah, I am impressed with myself. I'm absolutely not gonna lie. And we're gonna do side A, side let's do this. Man, what makes the most sense? I'm just gonna name, I don't know if like clockwise or one way or another makes more sense, but we'll just do it like this.
I
But
don't
this
think
is,
it matters.
yeah. I was thinking if we did it clockwise, if it'd be easier to like think about, but I don't think it matters. And we'll do that. And you know, this feels like a lot of work. You know, and I know folks were saying that yesterday with like all the hard coding stuff. Like the more upfront planning you do before you write code, the more time you'll save. Because the hard part, you all are learning a lot of the mechanics. So yes, like typos, getting syntax and stuff right takes time and those skills will build up, but you'll also find very quickly like thinking through and understanding the problem actually takes a huge amount of time. And what all these studies have shown is that like the sooner you catch a bug or a bad decision earlier in the process, the less time it takes to fix. Like if I'm writing out my pseudocode and I find that I have an error in my approach, it's way easier to fix it than like 2 hours later when I'm knee-deep in coding. So now I'm not going to get confused about which side is which side, because I've got sides A, B, and C, and I can go ahead and pass these as arguments. And let's go ahead and set these. So we've got side A equals side A. And we'll do that for side B. And we'll do that for side C. Awesome. I don't know if I remember off the top of my head the formula to calculate the area of a triangle.
I know because apparently I'm very excited about triangles and I've already been Googling stuff.
I love it. What is the
area,
formula?
It's half times base times height. It doesn't matter which one the base is or which one the height is. So it's half of one side times any other side.
So 0.5 times base. Height we don't necessarily have because that's not necessarily one side of our triangle.
That's going to be either side B or side C. It's just one of the other sides.
What if we have an equilateral triangle? Isn't the height just straight up from side A to the top of it?
Oh, yeah. Sorry, yeah.
Let's use our friend ChatGPT. Calculate triangle heights from sides. If we can't, we'll just calculate the perimeter because really the goal of this is to write some class methods. It's not to do the crazy math. In fact, I'm already kind of feeling an urge to skip all of this. I'm not gonna lie. Triangle area from sides Python. I am not, you know, normally I would say we should be working this out on our own. Clearly, this is sort of outside scope of like the main goal here. So I don't necessarily mind using ChatGPT for this. Plus, we can learn a little bit along the way. And apparently there's a formula called Heron's formula, who is presumably some long dead mathematician who came up with something very clever. So I'm going to borrow this. I'm not going to copy and paste it because that's when mistakes are made. ChatGPT is pretty good, but it's not perfect. So you know, if I was doing this for real, I would do a little bit of double checking, but I think this is okay for now. And I don't know what a semi-perimeter is. It mentions that, so let's actually ask it. Oh, it's just half the perimeter of the triangle. Okay, that's fine. Let's make that a separate method, just for fun. And that should be side A plus side B plus side C over 2. And that makes perfect sense. That's all the perimeters added up divided by 2. So, by the way, one benefit of making this its own method is I can write a test for it to make sure it's correct. And now let's calculate our area. So we've got semi-perimeter, which is self.calculate semi-perimeter. And this is actually a great example of why classes and instance methods and attributes are nice. Because when I'm reading this area method, I can look at this algorithm and this code at a higher level. I've got a method that does all this work here. I've named it something simple and understandable. And now let's go ahead and let's calculate the area. And I am going to need to import the math, Python's math class from its standard library. And there's a lot of, I'm just going to make this SP because we're going to be using this a lot. So let's do, and in fact, I am going to name this S so that it's even easier to copy this out. And in hindsight, naming these like A, B, and C might have been a bit better, but this is simple. This is explicit, so it's not bad. And let's just call that good enough. And let's just make a triangle, an equilateral triangle. And just see if we get something back. I don't even know if it's going to be right or not, but let's just see if we get something back that we don't have any errors. Okay, I got a number back. I'm honestly not even going to care about if that's correct or not right now, because we have enough here that's real that we can get to the good part of making some class methods. So can I get a volunteer to walk me through writing a class method to create an equilateral triangle?
Go up to line 60. The end of line 60.
Okay.
Thank you. And then define, calculate semi-perimeter. Actually, you could just copy the code.
Is this for creating an equilateral triangle?
No, I was gonna add calculate semi-perimeter.
Oh, no, we have that. We can circle back to that. Right now, I just want to, the same way that we made a class method here, like a sort of helper class method to create a square. Let's do that for an equilateral triangle. So I don't have to, type in 777 and possibly make a typo when I want to make an equilateral triangle. Does that make sense?
I'll pass this to someone else then.
All right. Anyone want to take a shot at it? Well, what's the first thing I want to do if I'm making a class method involving our friend the @ symbol?
At
Add
class.
decorator.
Yeah, I got to use the class method decorator. And what's a good name for a method that we're going to use to create an equilateral triangle? Not a trick question, I promise.
Equilateral try.
Yeah, you should always start method names with a verb. So I'll just throw create equilateral try. Now that we're using try, we should use this everywhere where we're referencing triangles for consistency. And when I create a class method, do I want to put self as the first argument, or do I want to put something else?
CLS.
Yeah, because we're not passing in an instance of a triangle, we're passing in the triangle class itself. And what is CLS a placeholder for?
Class.
Yeah, it's a placeholder for the class. And what other information do I need to create an equilateral triangle that I'm going to have to pass into this class method as an argument?
Side length.
Yeah, each side of the triangle is going to have the same length. That's what an equilateral triangle is. But I need to know what that side length should be. And just the same way, where if I was writing code, I would do, you know, triangle, side length, side length, side length. And you can actually do this, by the way. This will work just fine. But we have this nice placeholder here that we can use instead. So I'm going to just use that instead of the class name. And now I've got a class method that will create an equilateral triangle for me. How about an isosceles triangle? Someone want to walk me through doing that?
Would it be the same thing as the one above?
Close. With an isosceles, right? What's the difference between an equilateral and isosceles triangle? It's that if I have it right, two sides are the same, but the third side is not.
Got you. Yeah, so would it be two more like side length and well, yeah, side A or side B?
Yeah,
Or-
exactly. And I'm going to use side A just because in my mind, side A is always the base. And that's how I think about an isosceles triangle, as the base being the one that's different. And we'll just call this side length BC. Right? There's probably a better name, but that at least gets us halfway there. And Gary, go ahead and take us home on this.
Return.
Or yes, and I apologize. I got confused. I think I heard Mikhail, I know you started us off, but Gary, you're already on a roll here, so please do go ahead and take us home.
Return.
Hey,
In
Chris
class.
started us off.
Open. What do you say?
I think Chris started us off. You confused us.
Oh, Chris,
Oh,
I'm
dude.
confusing everyone. I just need a second monitor so I can have
I
this
understand.
up. I apologize, guys.
It's all
I've got
good.
I've got the grid on like half my screen and Slack on the other half.
Oh man. You want to finish it, Chris? Or I guess
Go for it.
you do side you do side A and side B. Or BC. Yeah.
Yes.
And then one more of these, right?
Yes.
Yeah, because I need to pass in 3 of these. Yeah, there's gonna be more than enough problems to go around. Normally what I do is I just randomize a list of everyone and then share the list and then just run it down when I'm kind of calling on folks. But I didn't do that today. Awesome. Thank you guys. And so now we have 2 class methods, and we have a nice way of creating an equilateral triangle and a nice way of creating an isosceles triangle. So over here, instead of doing this, I can do triangle dot create equilateral tri, like 7. And when I want to create my isosceles, I can do triangle dot create isosceles of, oh, I don't know, maybe 7 and 4. Though that is probably not actually possible. We did not add any like validation in, and I'm sure there is. If I try to think of like a huge base and like tiny sides for the isosceles, I don't think that works. So that's a mission for another day, is to actually make this, you know, tell us if our isosceles triangle is bad. But that's actually a great example of something that might go in here. And in fact, if I ask ChatGPT like how to check if sides are valid for an isosceles triangle, let's see if there's an easy way to do it. The sides must satisfy some theorem, which states that the sum of the lengths of any two sides must be greater than the length of the remaining side. So I think an easy way to do this is if the sum of the lengths of any two sides, like let's say just side A plus side, right, one of those sides, it has to be greater than the length of side of this one.
No, it means
Else.
if two
Yep.
of the side length BCs, you want the base is going to be 1, right?
The base is 1, yes.
Yep. Okay. Yeah, that's all right.
Yeah, I think that's right.
Okay. Yeah. Thanks.
Yeah, it could be wrong, to be honest. And to be totally honest, even if I have this wrong, it's not so relevant right now. Just I think this is a good demonstration too of the value of a class method, is we can add in some like specific validation to an isosceles triangle in there. And now if I do something crazy like make the two sides of my isosceles 2 and I run this, then I'm not sure if I got the error formula right, to be honest. But we can, as I said, that's sort of just the icing on the cake. The last kind of method I want to introduce here is what's called a static method. A static method, like a class method, we use a decorator to create. Unlike a class method or an instance method, we don't pass in class or self. It's actually totally independent. So like the example here is not a bad example, and I think I'll code that up just to get us started. Maybe we have a string utilities class, and I want to create a static method. And just like a class method, I do need to use a decorator so that Python knows this is not an instance method for the class. And I am just going to copy this bit of code out. And let's see, a palindrome, I want to say, is a word where it's the same way both sides. I always get this confused with an anagram. Does that sound right to folks? And I'm pretty darn sure that's the case. Because can someone remind me, what does this notation here do to a string? This funky like bracket double colon
Doesn't
minus
that
1.
iterate backwards?
Yeah. Like if I go ahead, like let's run the Python REPL and let's just have a string here, like hello world, and let's do bracket bracket minus 1. It flips it around backwards. It iterates through it backwards. So we're comparing a string to its reversed self here, which is what a palindrome is. And the example here is race car too. So I can go ahead and I can use this without having to create an instance of the string utils class at all. Because note that there's no self in here. and in fact, if I put self, it would break or Python would be unhappy, and it's not how this is meant to be used. But right, maybe I have like 5 or 10 of these different methods, and I just want them all in one class because it's easy to share. And so now I've got this is palindrome method. I'm trying to think of like a good example of a static method for triangle or circle or rectangle. If anyone has any thoughts, let me know. Like, I think there's a lot of things we could make up. Sometimes maybe you want to move some of this validation logic into a static method if you want to use it in multiple places. But sort of like stuff like this is a good example of what static methods end up getting used for. I'm trying to think if there's a good one for a triangle. Murad, yes, sir.
I didn't understand the static method. I'm sorry.
Yeah, no worries. I know, and that's why we're kind of covering over this stuff as well. A static method is a method that isn't specific to an instance, and we don't have this class argument here, so there's no special way to use it. I could actually put a class in here, but it's meant to be used as sort of a utility method, like as you see here for string utils is palindrome, race car. Like I might import this and use this in multiple places, or trying to think of a good example of a static method to create. I saw someone else with their hand up.
Well, I was just gonna make the comparison to like the built-in methods in Python. So like my understanding would be like, let's say we're talking about lists and you have like a class of lists. If you're gonna do split, that would be a static method on like the list class, for example, right?
I want to say yes. I'm not sure off the top of my head, to be honest, for split. It would depend how you're calling it. If you're calling out an instance of a list, then it's an instance method. Is it called, what's the method that again that you're talking about?
I didn't want to get into specifics, just more kind of like, and I guess it would be a string method if you're using split, now that I think about it, but just how methods are defined under the hood for the built-ins, I would think would be a static method, right?
Yeah, there's definitely a couple. Let's see if we can find a good one. It depends. Like if I have, so not sure if split is Python or JS. And I think we would have to add what a separator here. There we go. So this is actually not a static method. This is actually an instance method. So like for the sake of, because if you look at how this method is being called, we're calling it on an instance of a string. And if I, let's if it helps to make it a little clearer, here's a variable, hello, that holds the string hello world. Hello dot split. Right. If I was doing not even sure what the str class is. So in Python, the string class is named str, I think. So if I was doing str split, and then passing something in as an argument. Ah, and actually that does work as well, which I had not realized. So that probably is defined as a static method. And Python probably has it in both places, in fact. So I apologize because I was about to be like, nope, that's not a good example. But it looks like Python may have it in more than one spot. But what I want to point out, because I think when we're writing code, this is the easiest way to tell, is if I'm calling a method on a individual instance, like here I'm calling it on a specific instance of a string, this hello, that's how you can tell that something's an instance method. When I'm calling it off of the class itself, like right here, that's how you can tell that it is a static method. Like, for the sake of argument, let's just go to our circle class. I don't know why we would want to do this, but let's just say for the sake of argument, I wanted to make a static method to calculate diameter. And I believe the formula for a circle's diameter is twice the radius. I think I was thinking of circumference, which is 2 pi r. But let's just do diameter just for simplicity. You know, we probably would want this as an instance method, but just to kind of demonstrate this in action, let's say I've got my circle here, right? And I can calculate its area. If I do my circle dot calculate a diameter, I see, okay, Python is sort of helping us, but making it a little bit more confusing with the static methods. And in fact, when I try to call this static method, we get this argument missing a positional argument radius, because I can't access self inside a static method. This should throw me an error. Right? And I get this name error, self is not defined, because a static method is not meant to be called on an instance of a class. So really the way to do this would be, again, this is a little bit of a contrived example, so I apologize, but
Hey, Adam, I put this in the chat, but wouldn't the total class method earlier be a good idea of a static class? Because total class belongs to the class of students, but it really doesn't belong to any single student.
oh, you mean the list of all students from before?
Yeah. I'm just trying to think of like a real example here where it's like,
Yeah. Well, we have that as a class attribute. It's not, there's not like a method we need to call on it.
okay, never mind. Go back to your contrived one. Never mind.
No, it's all good. And the truth is, like, it's a little bit of a fuzzy line between when to use a class method and a static method. This is not the worst example of a static method. Like, maybe we have things that aren't circles, but we want to know what their diameter would be if they were a circle. That's a good example of why we might create a static method. You'll see it for string utilities as well. The important thing to note here, I think, is the way that a static method is used and what it can and cannot do. A static method has to be used off of the class. It's not a particular instance, and you don't have access to self within a static method, and you're not really meant to. So that's the big difference. And that's sort of similar to class methods in that you don't have access to self there either. Let me just kind of run through these sort of like general best practices that we have and sort of reminders, because these are useful. And I do know that this can be, I think, a bit confusing. And the truth is, like 80% of the time, if not more, you'll be writing instance methods. So a class method is used on the class itself, not a particular instance. If we wanted maybe to like, I don't know, print all the students from the all students list or find a particular student in the all students list, that's a good example of a class method. To go back to the example from before, we have this all students list. Well, maybe I want like find a student. That would make sense to write as a class method, right? And in fact, we can do that right now. If I, it's going to be in practice. We have this all students array. You know, maybe I want to be able to find a student by ID. And actually, can someone remind me what's the best way to find if someone's in a list in Python?
Yeah, I think you just do the variable and then
Yeah,
and then the
thank you.
list.
I'm so used to JavaScript that I still, I don't think it's in, it's probably in, is it includes?
Oh, I meant like without using a method.
Oh, I see what you're saying. Yes,
Yep.
you're absolutely right. Thank you. Yep. If class, that probably won't work for searching by ID, but we can modify it for this the moment. Well, let's actually use ChatGPT.
If ID in find a student's dot keys. Cause it would be a key, right? The ID is?
We have a list of
Oh, it's a
class
list.
instances. Yeah. Find object in list of objects by ID, Python. And let's see what ChatGPT says. I should know this. A lot of this stuff, just JavaScript just doesn't have this stuff, so I'm still a little more used to it. So this is like the less good way to do it, just looping through. I'm sure there's a more succinct way to write it, but this will serve our purposes. So we can just do for S in class dot all students. If S dot get ID equals ID, return S. Otherwise, we'll just print student not found. So this is a great example of a class method, actually, because we see in action, we're interacting with our class attribute, all students. It's not specific to an individual student. And then if I was to use this, I would do something like student, find a student for, right? And maybe, you know, that's the student that we're looking for. So that's a good example of a class method as well. The reality is you could write this as a static method too, if you wanted to. And it doesn't make a huge difference. It would end up looking like this. We just have to get rid of the class. And then over here, we write student. It's probably a bit better to write this as a class method. It communicates intent a bit more. There are certain things where when you start inheriting classes where it starts to matter. But you know, you can do this. And I'm trying to think if there's a good static method for a student, and then we can kind of wrap up because we ran a bit long. But you know, maybe we want a list of well, I don't even know if this would probably be better as an attribute, truthfully, but let's just code this up as a static method for purposes of example. Maybe we want a list of all possible grades, right? And I'm thinking 4th grade, 5th grade, 6th grade, 7th grade is what I mean by this. And so maybe we just want a method that returns this. Or maybe to make it, a bit more, maybe we have like all grades equals 1, 2, 3, 4, 5, 6. And maybe this is like a print grades method. And we do something like for grade in student all grades, print grade. Maybe we need a utility method like this because sometimes we just want to be able to nicely print all the different grades that the students could be in. And again, we could make that a class method if we wanted. You can kind of see how a static method makes sense here because we're not really interacting with data that changes. And so then down here, I could say, student print grades. And to get a list of all the different grades that students could possibly be in. And Dustin, yes, sir, I see your hand up.
Yeah. I was just gonna say, like, the static would be like math calculations or something, right? You're not changing an addition, you're not changing how something adds, you're just changing the values of X and Y, right? So it'd be like you have static addition, multiplication, subtraction. You're not changing anything in there, you're just able to change the values of X and Y.
Yeah, exactly. Like a static method is for when I don't actually want to change stuff about like an instance, about an individual student, about the list of all students. It's more sort of utility stuff like this.
So like it would, like a static for this could be how grades are calculated, right? Like how it's calculated wouldn't change, but the values of what is being calculated is changing. Like their grades, right? So if you had X and Y, it's not changing how X and Y equals C, it's just changing the value of X and Y.
Yeah, I think that's
like a math operation, like any math operations, it's set how it is, you're just changing the value of it.
Yeah, I think that's a good way to think about it. Brandon, yes, sir.
Did Murad have his hand up first? I don't want to go before him.
Oh, Murad, please. Thank you, Brandon.
I just, so do you mean the static? It just function inside the class, do something, okay, do its job or its work, okay, but it doesn't move or go to take its argument from another function inside the class,
from instances of the class.
It's like isolated. It just do its work and take the argument from outside.
Yeah, exactly. That's a good way to put it. Static methods are isolated. They only take their arguments from outside. Like, if I try to do self in here, it will throw an error, and that should be an instance method. And yeah, so static methods and just kind of looking at this might help. They're really independent of instances and instant state, right? It's not about you know, the area of this particular circle. It's not about this student or that student. It's not about class like attributes like all students and stuff like that. They're really they're what they're good for is like utility functions that are related to a class, but we don't need like data specific to an individual student or an instance. And they're good for things like code organization and readability as well. And so you don't see a ton of them, to be honest. You're not going to be writing them very often. Most of what you'll all will be writing are instance methods, which you're familiar with, because, you know, if I want to calculate a student's grade, it's nice to write an instance method like calculate grade, or I should say calculate GPA, and then I can grab all the data for that individual student using self, and I don't have to pass in a ton of arguments. So like 80 to 90% of the OOP stuff you'll be writing will be using instance methods. Class methods you use every now and then. And I think the triangle example is a really good one, right? Like these, you could make these static methods too, by the way, if you wanted. It wouldn't be that big a deal. But these are not instance methods, right? It's not about a specific triangle. And the goal here is to really like give us some helper utility function for like creating a certain kind of triangle. But so that's where this is a really good example of what to use a class method for. Again, if you wanted, this could also be a static method. And Brandon, yes, sir.
I think I may have misunderstood class method a little bit. Does it always have to have class pass into it?
It does.
Okay, then my question is going to be a little weird then. But in terms of like like as an example, the code I had earlier where I manipulated and used the class variables, would it be preferred to have like methods that manipulate those variables within the class, or is it okay to have it in like your main code? Like for
Oh, you mean
organization and grouping purposes. That's why I was wondering if it was a class method because it manipulated the class variables.
I would have to see it, to be honest, because, you know, especially with the car management program, right? Like if I need to maybe like remove an individual car from some list of all cars or something, I could see a case where maybe that's an instance method. I think the best way to think about it is, you know, when I'm writing a method, is it meant to like be used on like an individual instance of my class? Or not?
I also am reading the best practices for the first bullet point where it says these methods can be used to modify class attributes, which is why I was thinking that way. And I was confused as to why you would need to pass the class in there as well if you're modifying class attributes. That entire paragraph, yeah. Oh, you were.
There we go. These can be used to modify class attributes. So yeah, this is just the way that a class method works. Like the same way that when I'm writing an instance method, I need to pass in self. So I can then access all the attributes and methods on that instance. The way a class method works is I need to pass in class, which I can use to access all of the attributes and methods on that class, as well as the init method for that class.
Okay.
But yeah, like if for some reason we had a class attribute over here, and for some reason then in my class method, I could do, you know, CLS, I could access that class attribute this way.
So if you were returning, like, for example, the list of students or the list of cars, would that be in a class method or an instance method?
Probably a class method.
But you would still pass class. This is what I'm confused about is why you would pass class into a method that does that, because
Right, like why do I have to pass, like, you mean why can't I just do something like this?
well, not I guess this is a bad example, but in terms of like that list of you know, when you push, whenever you init and you push to a list.
Well, let's take the all students as an example
Yes.
for a sec. So we've got all students. We've kind of covered some of this stuff. We have this class method find a student. And let's say you're kind of saying like, hey, let's make a method. Let's just say for the sake of argument, we're going to call it what? Get all students. And it should return that list of all students.
Yes.
Awesome. So this works in Python. As I've been saying, just please don't do it because it will cause a lot of confusion. And the better way to think about it is all students is a class attribute. So to access it, just the same way, like if I want to access, you know, self.name, I need self there. I need to access the name attribute on this instance. I need to access on this class the attribute that I care about, this list of all students.
Okay, I think I'm seeing where this is going.
And if I want to, I can make this a static method. Excuse me. This works perfectly fine. And then the way I would call this code, and I'll just put this, let's just put this over here. I would call it like this. If for some reason I wanted to make this an instance method, I could. And then I would call it like this. I would need a student, you know, like my student, get all students. But this doesn't make a lot of sense, both in terms of how we're going to use it and in terms of other people reading this code and some other things not worth getting into right now. Right? So we probably don't want to make an instance method that does this. Right? Because a lot of this is about like, when the programs get bigger, it starts to matter more. But a lot of this is about like communicating intent and kind of making our lives easier. And this communicates intent really well to other programmers.
Sorry.
Yes, sir.
So you could write it as class method and then pass in class and then do class dot all students.
Exactly. You hit the nail on the head.
Yeah, okay.
Yeah, great question, man. And I think this was great to walk through. And I'm sure for other folks as well. And you would run this code and run this method the exact same way. You still have to do student.get all students. But this gives you that placeholder for the class.
Is it preferable to access the class information like this or through code in main?
Honestly, it really depends.
Okay.
Yeah, there's not necessarily one right way to do it. I would it just depends, I think is the short answer. Right now, a lot of this stuff with class method and static methods, I think is just about learning the techniques. I think the more you do it, the more it will start to make sense. Just to sort of reiterate some good practices here, regardless of whether it's a class method or a static method or an instance method, give your methods good names. They should always start with a verb, and it helps you design better programs. Kind of try to follow the single responsibility principle of having like each method do one specific thing. I do recommend writing some comments for documentation and using methods to encapsulate logic that you might reuse for reusability. And again, just to reiterate, most of what you'll be doing is instance methods. You're not going to be doing tons and tons of class methods and static methods. They're sort of the exception to the rule. But what they're good for is stuff that's not about an individual instance. And I see a couple hands up, and then we definitely should stop because we've gone a bit into lunch. So maybe folks got their questions addressed, or maybe I just missed seeing folks.
Yeah, I had my hand up, but you answered my question though.
Oh, perfect. Okay, awesome. And I think a lot of this, like that's like in these assignments, we're going to kind of be telling you which ones to create. And part of that is to see good patterns. And again, I'm just going to come back to our triangle class again, because I think these are really good examples of class methods. And let me fix my typo right there. Right, because this is not about a particular instance of a triangle. We haven't even created it yet. It's about a helper to create triangles. And I probably didn't describe that very well, but I think that these are great examples of what class methods are good for, right? Because now I can import this triangle class anywhere, and I can create an equilateral triangle really easily. I can create an isosceles triangle really easily. I can have my error checking logic and all that. And my init method stays clean and general case and simple, right? For any kind of triangle. And so I think that's where it really becomes useful. And like Dustin was saying, maybe we end up needing something that we need to check all the time, everywhere, like with valid triangle sides, and maybe that would end up being a static method or something like that. But then, for individual triangles, we want to calculate the area, we want to calculate perimeter. If I really wanted to, I could make a static method, like calculate perimeter. And like return side A plus side B plus side C. And then I would use it something like triangle calculate perimeter. I don't know, let's just do like 3, 4, 5. And maybe, as I write more code, it turns out that I need that. But I probably don't need that. I probably don't want this to be a static method, because I'm probably interested in the perimeter of a triangle that I've already created. So I can do self dot side A plus self dot side B plus self dot side C. And then I can do this.
Question, Adam.
Yes, sir.
So if you take the 3 sides, and there are functions out there that you can use to determine the angles, and all of the angles have a total 180. And so you can give sides that make a non-valid triangle.
Yeah.
So would that checking be a good static method, or would that be more of part of the class?
I think that's a pretty good example of a static method. Also, especially because we might use it in multiple places, and it might be useful to have.
Because you could actually just have them put in the sides, calculate the angles, store them somewhere, and it's part of, as part of but that's part of the instance too. This is why I don't know. I can see this going in multiple different places.
Well, here's the nice thing about this. Do stuff. This makes a lot of sense, because what I can do with this is, if triangle is valid triangle, side A, side B, side C, do all this stuff, right? This makes a lot of sense as a static method, because I might use this in a bunch of places. Like you were saying, I might want to use this outside of the class entirely in some other code with some other checking. And I might need to, maybe I want to use it somewhere else as well. But this way I can have my logic. Yeah, this is a great example actually of a static method. Right, because I can use this inside my init method, and we obviously want to check if a triangle is valid or not before we make it. But I might want to use this elsewhere. And this is, you can kind of see the advantages of class methods too, because I don't need to add this to my class methods, because the class methods call the init method. And I've got my error checking right there in the init method, so it gets called every time. Yeah, so that's a great example of like a good use case for a static method. Again, these are all just tools in the toolbox. There's most of the time, there's not a wrong way to do it. So I think the most important thing now is not getting too lost in one versus another. Because even if you get the code working, and then when you do code review with your team later, you guys are like, oh, maybe this should have been a static method instead of a class method, or whatever it may be. That's okay. That's what this is for. And at the end of the day, there's a lot of different ways to skin the cat. And there's a lot of tools in the toolbox. So all of this stuff is really, guidelines. And there's a few like, hard requirements, and there's a few things, like Python will just throw an error if I try to do, self.side A. That just doesn't work inside a static method, because a static method doesn't have access to self to any particular instance of a class. But really, these are guidelines. Let me go ahead and stop the recording because we have run long, and just quickly lay out the afternoon agenda. And then I did see one or two more questions, which I'd be happy to cover.